Hello, and welcome to this video presentation. We will be discussing the importance of the social brain in context of education. This presentation will be focusing and acknowledging the role that the environment plays in shaping and molding the brain. Most of the information that will be presented can be found in Peter Russo's The Social Brain and Education, which will be linked at the end of this presentation. Neuroscientists now know that the processes involved in the brain's development does not stop at any point, and that the brain continues to grow and change during its daily interactions with the environment. These daily interactions form the basis of what drives human beings to learn, integrate, explore, and thrive. The system that drives human beings can, however, be altered and changed through the experience of trauma, fear, and risk of survival. As stated before, these experiences do not stop development, but alter it. What this means is that environments that are conducive to trauma, fear, and risk of survival alter the course of neural development and changes the direction in which memory systems are formed. When putting this information in an educational setting, student tests and assessment may show comparable results, but this new information shows that the source of what drives the system could be vastly different depending on the individual student's environment. Now that we have established that brain development doesn't stop, but continues in an altered state due to environmental factors, let's take a look at the beginning development of the brain. The first areas of the brain that are developed are the primitive systems, also called the primitive neural complex. The primitive neural complex consists of systems that are purely responsible for survival. These consist of systems in charge of breathing, heart rate, and the ability to procreate. The primitive systems include the brainstem, pons, medulla, and part of the cerebellum. These are all fully developed and functional at birth. The second part of the brain that develops is the paleomammalian cortex, also referred to as the midbrain. These structures contain the thalamus, amygdala, hypothalamus, hippocampus, and the basal ganglia, all of which are jointly responsible for the activation of the stress response. Unlike the primitive systems, this neural section is fully developed at birth, but is not fully operational. Lastly, the cortical regions of the brain develop. This is the largest part of the cortical mass that develops. Most of its connections are made after birth. The brain will continue to organize and reorganize itself as a result of information processing from the external environment and later from a combination of environmental and frontal cortical processing factors. This final stage of development relies on the collaboration between the primitive regions. So, how does the environmental impact on the development of the brain alter the systems that have an impact on education? When the external environment provides safe, secure, and manageable cues, the stress response, which is activated by the midbrain, is limited, and the connections between the primitive systems and the cortical regions of the brain develops open neural activations. If these external environments are compromised, they enhance the risk of neural patterns of avoidance to facilitate patterns of neural protection. The impact this has on students is decreased social development, which compromises frontal cortical activation. Memory systems are activated in both an enriched environment and a compromised environment, but the nature of these networks becomes unique. Memory systems that are linked to threat lead to fear-based or closed reactions, which are created to enhance survival. Memory systems that are linked to enriched environments lead to open neural patterns, which increase cortical blood flow to the frontal cortical areas and enhance problem-solving capacities. When fear-based or survival patterns are activated, the memory systems respond according to the fear-based systems. And when learning becomes fear-based, the focus is placed on limbic activation. This means that the response is nearly immediate and learning is quick. The downside for this process is that it remains as a survival response, and the threat will be avoided through protective and survival learning. While fear-based learning is much more powerful than open neural activation, as it is driven by the basic human need to survive, the ongoing release of stress chemicals becomes detrimental, and the result is long-term performance deterioration. When a stressor is manageable, it leads to cortical activation and the formation of memory networks towards the frontal cortical systems. This process is referred to as controllable incongruence. As said before, when the stressor impact becomes significant, it shifts cortical blood flow toward limbic areas and downregulates activation to frontal areas so that memory systems are enhanced in fear-based regions. This then creates a pattern of survival or avoidance behaviors. In order to provide a positive balance of stress responses to encourage effective learning and cortical activation, there are 7 educational indicators that will maximize wellness and capacity. The first is the need for a supportive teacher-student relationship. This is important as without the facilitation of an effective relationship that addresses the basic need for attachment in the educational environment, primitive fear-based systems are not effectively downregulated. The next is the need to increase latency periods when engaging with students. Latency refers to the amount of time that lapses between when a student is given a response opportunity and when the opportunity is interrupted. Research indicates that the smarter or more popular students are given more latency periods than less liked students. This relates back to the compromised environment, altering the brain's social development in the frontal cortical activation. Asking open questions rather than direct questions. This has been shown that direct questions upregulate a sense of distress. To limit distress, open questions that have hints and clues assist in increasing student interest, collaboration, and safety. The next is encouragement. All teachers know that encouragement has significant neurobiological effects. Encouragement enhances the student-teacher relationship by downregulating the primitive responses and upregulating the cortical regions of the brain. Encouragement increases motivation, which in turn will lead to more neural activation and releases key neurotransmitters such as endorphins and dopamine, which will assist in the completion of tasks and enhance plasticity through ongoing engagement. The next is respect. Respect also has significant neurobiological effects. If a student feels respected, their patterns of engagement will be enhanced through their sense of survival and being accepted, while inhibiting fear and facilitate neural activation of the key social and cognitive frontal cortical areas. The next indicator is enthusiasm and passion. Studies on mirror neurons have demonstrated that humans learn many skills through observation. This, like many other things, can be helpful or detrimental, depending on the environment. A teacher that demonstrates enthusiasm and teaches with passion will be able to facilitate similar responses in the student and enhance the learning outcomes. The final educational indicator is an enriched environment. An enriched environment means that safety needs to be present. Teachers should focus on a trustworthy environment that is conducive to emotional warmth, acceptance, and a sense of belonging. This is so the student can develop and is encouraged to laugh, play, and thrive. The environment should also facilitate a positive collaboration between home and school. The development of the brain is a social or environmental experience-driven interaction that requires a close look at the social systems in order to make predictions such as what can students do. If education and teaching is to become more successful towards student learning, the systems in place need to be driven by a socially responsible agenda that understands the challenges and potential of the interactive developing brain and encourages positive environments that assist in the positive developments for students to thrive. Thank you for listening.